Introducing the Lewis structure. The Lewis structure is named after Gilbert N. Lewis, who introduced it in his 1916 article, The Atom and the Molecule. Lewis structures extend the concept of the electron dot diagram by adding lines between atoms to represent shared pairs in a chemical bond. How to create Lewis structures? Step 1. Find the total valence electron. For example, H2O. To find the total valence electrons, we will base it on the periodic table. In the periodic table, hydrogen is in group 1, therefore it only has one valence electron. So we will write one valence electron for hydrogen. But don't forget the subscript of hydrogen. The subscript is 2, so meaning we multiply the total valence electrons of hydrogen by 2. Then for oxygen, we will add 6 because it is located in group 6 in the periodic table. Then we will add all of their valence electrons. So H2O has a total of 8 valence electrons. Step 2. Find the central atom. How to find the central atom?
To find the central atom, place the least electronegative atom or the atom in the center. So how would you know that it is the least electronegative atom? Just remember, fluorine is the most electronegative, then followed by oxygen.
So as you move away from fluorine and oxygen, the atoms become less electronegative. So that means those atoms go to the center.
For example, H2O. Hydrogen is more further away from fluorine than oxygen. But take note, hydrogen can never make more than one bond and thus can never be the central atom. Therefore, oxygen will become our central atom. How to make atoms happy? An atom is considered happy when its outer electron shell is filled with 8 electrons, in accordance with the octet rule. Octet means 8 valence electrons. For H2O, we have a total of 8 electrons, 1 for each hydrogen and 6 for oxygen. Put the 2 electrons between the atoms to form a chemical bond. Now we completed the octet for oxygen, which has 8 valence electrons. For the basic Lewis structure, the biggest exception is hydrogen. It only needs 2 valence electrons. But what happens when you use all of your valence electrons and you still haven't completed the octet for each element of the molecule? We're gonna move some valence electrons from the outside to the inside to share them to form a double or triple bond. For example, O2. If we followed all the rules and count the valence electrons, it's 12. We'll put the bond between them and fill the outer shell. We will end up with this situation. We'll have an octet with this oxygen, but this oxygen only has 6 valence electrons. It doesn't have an octet, and there are no more valence electrons. To solve this problem, we can take this and move it to the center and share them, and form a double bond between the 2 octet electrons. But now, this oxygen has an octet, and that oxygen has an octet too. Step 4. Calculate formal charge. Formal charges allow us to figure out the electric charge of the molecule. To calculate the formal charge, we will use this formula. Formal charge equals valence electrons minus non-bonding electrons minus half of the bonding. For example, H2O, water. We will start with hydrogen. In the periodic table, hydrogen belongs in group 1, so it has a total of 1 valence electrons. As you can see, there are no non-bonded electrons. Then, we have a total of 2 bonded electrons for hydrogen. But wait, don't forget we only need half of the bonded electrons. 2 divided by 2 is 1, so we write 1. So we have 1 minus 0 minus 1. Hydrogen is a neutral element. Now we have oxygen. Oxygen is in group 6, so it has 6 valence electrons. Then we subtract all the non-bonded electrons, which we have 4. Now, we have a total of 4 bonded electrons. But don't forget that we only need half of them. So 4 divided by 2 is 2. Now we have 6 minus 4 minus 2. Therefore, we have a 0 or a neutral charge for oxygen as well. So in conclusion, when we add the formal charges of oxygen and hydrogen together, H2O has a formal charge of 0 or it has a neutral charge. Thank you for watching our video. Please like and subscribe, and most especially please share this to your friends. Thank you.